Hello, I'm Nicole Nowak, and I'm going to be talking to you about our consumption and production project for BE 1500. My group is number 5, and my access ID is EC3354. So let's get started. So what we did with our project was took production and consumption of energy in the U.S. and looked at it, all the different variables in it. So our data goes from 1973 to halfway through 2017, and it looks at months, years, and different sectors, and talks about the data of energy or consumption that were output. And our project is useful for looking at trends between the data. So we find some max and mins, we find future data predictions. We look at trends over the years, over the months, between sectors, and we do this by using mostly menus. That's how our user is going to go through this. It's pretty easy to do. You just click on menus that keep being prompted to you, and if there's not a menu prompted, either a graph is outputted or our command window is asking for an inputted year. What we output in this project is mostly statistics, a lot of scatter plots, some with lines of best fit on them, and then we have bar charts and pie charts. So I'm going to start by explaining all of our functions, and then I'm going to go through and explain the main code. So our first function is variables, and this takes an input of the production and consumption data from our Excel files, and it outputs a bunch of cell arrays that have data in it that we use throughout all of our functions to have stuff to plot and look at, to have data. So variables uses for loops and nested loops to pick out data from our Excel sheet. Our Excel sheet starts with January of 1973 and ends in I believe like June of 2017. So each row is a month, and then after 12 rows, it'll go to another year. So that's how I sorted the data. Every 12 lines I would skip, and then that would be the beginning of the month or a new year of January. So that's why I sorted all of the cell arrays. I did this for months, I did it for years, and then I use my nested loop to do sectors of months and sectors of years, looking at production and consumption of all of them. So that's how we did some data manipulation. Our second function I want to talk about is max and min. So this inputs A, which is the first menu that pops up, which decides between production and consumption, and then A1, which decides between whether or not you're looking at years or months. And then the row correlates to the row in the cell array that you're going to pick the data out of, which is inputted by the user when they decide between what month they want or what year they want. And then P and C are our variables for the Excel sheets, so production consumption, which gets sent automatically to the function variables so that these variables all exist inside the function. And so what max and min does is use switch cases and while loops to find what the max month or year and the min month or year is for whatever's inputted. So if we inputted 1980, it would say maybe March was the highest and June was the smallest. So I'll show you that later. And it does the same thing for years. So if you type in January, it'll say 1975 was the lowest for January and 2015 was the highest for January, and I'll show you that later. Our next one is mplot. Mplot plots a scatter plot of whatever we input again. So consumption, production, year, month, whether or not it's June, January, 1988, whatever the row is, goes to the variables first, get inputted, and then it sorts through our data and uses if-else statements to decide between what was inputted and switch case statements to decide the titles. And then it plots all of this with either months or years on the x-axis and the data that was taken out of the cell array on the y-axis. And it outputs an x and y, which is used later for our future function. The x is the x variables that it uses to plot, and the y is the y variables it uses to plot. So I'll talk about future next. Future takes those x and y's and it plugs them into polyfit to get the m and b variables so we can plot our line of best fit, and then it plots this line of best fit from 1973 to the future year that is inputted by the user. And then it evaluates this with polyval and plots it. And then it also plots the specific year that you asked for on the graph with a red asterisk so it stands out, and it'll output the value of SVAL, the estimated value. So future is how we use our line of best fit, and then we have pie chart, which is next, and that's the same thing, inputs production consumption, year, month, the row it correlates to, and then this time it inputs a sector that is taken from the user as well, and it looks at how that sector compares to all the sectors. So it takes the value of the one sector we looked at, which could be coal or wind production, depending on what you chose for A and A1 and sector. And then it takes the sum of all the sectors, and it'll create a pie chart with one slice being the sector you chose and the rest of the pie being the total of all the rest of the sectors, and it uses if-else statements to do this. And then bar chart compares actual data instead of just percentages, so it's the same thing with the A1 row and sector, but it plots a bar chart. The left side of the bar chart will be the sector that was chosen, and then the right side will be the total of all the sectors. So I'm going to run some of our main code just to show you what I mean. So we're going to run this. Let's say we want to look at production of 1 year, and let's say 2000. So now we can look at the max and mins. If we click max and mins, it turns out March was the greatest production and April was the lowest. So now if we want to do production, let's say of 1 year again, and we'll again do 2000, we're going to look at a couple of the different things. If we click the second option, that'll use our overall data information, which is the mplot, which plots the scatter plot for 2000, which each month on the x-axis and the value on the y-axis. So we can also look at production. We'll go of 1 year again, and we'll type in 2000 again, just stay the same. And then we can do view by sector. So we can do coal, and then you can look at percent, which will use the pie chart, or actual data, which will use the bar chart. So we'll run this first with percent. There's our pie chart. This is coal, and this is everything else. And then we'll run it with bar chart. We'll use coal again and bar chart. And so here's coal, and here's the others, and this is their actual value on the side. So basically this is all going to be run the same with consumption. So I'm going to show you future production because that's a little bit different. So future production uses our future and our mplot. So if we want to look at, let's say, January of 2090, it outputs the mplot for January all the way up to 2017, and then it plots our future production line of best fit all the way until 2090 with this little star here that shows that's the year you were looking at. And then on our screen it outputs the estimated value of 2090 and the value that is used from the polyval. So all of this can also be run with consumption. The exact same windows will come up, but I should finish with production first. So for production, everything you just did with year, you can now do with month. So you can choose a specific month, and then you can look at max and mins. So the max would be 2015, the min would be 1978. You could do overall information, and that will give you a scatter plot. Let's try that one more time. Production of 1 month, June, and then overall information. And then it plots a scatter plot for June. So all this can be run again for consumption. It has all the same options, and the outputs are run through the code the similar ways. So we use in our main code, it's mostly menus. So our first menu decides between production and consumption. Production and consumption up here. And then our next menu will go through years, months, or future production. All of those are used throughout the functions. And we use row and sector. So the row right here, after the user inputs the row, it creates, or it evaluates what it would actually be in the cell array. So you end up subtracting 1,972, and it does a similar thing with months, where it goes to a specific row. January correlates to 1, June to 6, etc. And same with sectors. The first sector correlates to the first row, and so on. So we wrote this as menus because we thought it would be easier for the user. And our group also had a better understanding of the if-else statements. So we used those because we thought that would be easier. And there's many different options that are very specific. So like consumption of a specific year, of a specific sector, or production of a specific month of a specific sector. So we had to go into great detail. So we had to use if-else statements that could go inside of each other. So this really helps with my understanding of MATLAB. The importance of pseudocode was key here because we would not have understood what was happening in each other's functions without it. It taught me the usefulness of the cell array, so we could use different size matrices, and with it just helped a lot with the organization and the helpfulness of the MATLAB debugging, all these little orange and red dots on the side that would tell me if my code was going to work, if I was missing an end statement, small mistakes I could make. And then this also helps with the different ways to plot using bar chart and using pie chart, which were totally new to me. So that is our function, or our project. And I hope you find it of good use when you're ever looking at production and consumption of energy in the US. Thank you.